one.
Hey, what's up, YouTube? It's been a while. Welcome back to the How to Learn Data Science in Python in the DataCamp episode number 18. Let me turn on the light very quick. Here we go. Okay. So today, I haven't been coding in Python for just a little bit while, so bear with me. But today we're just gonna keep going with the DataCamp stuff, and I'm just gonna talking about the data type, and actually Danny is going to talking about that. But let's turn off this line. Okay, so with further ado, let's just jump into it.
We'll cover more of the gritty details in data cleaning. We begin with working with data types. Here's an example data frame. We expect the name and sex columns to be strings, and both treatment values to be numerics. We can call the dtypes attribute on the data frame to get the types of each column. Here, you see that the name, sex, and treatment columns have a dtype of object, and a treatment B column is stored as an integer. The object dtype is a general representation in Python that is typically encoded as strings. Now that we know what dtype is stored in each column of our data frame, there may be times when we want to convert from one type to another. Numeric columns can be strings or vice versa, like our treatment A column example. We can convert the column to a string or object type, for example, by passing in the str parameter to the asType method of the column. Some variables, such as sex, are more than string objects. They actually represent different groups or categories. We can pass in category into the asType method to convert this column into a categorical variable. Here, you can see the changes to the dtypes of our data frame. For columns that contain categorical data, such as male, female, and a sex, converting data into categories have a few use cases. They make the data frame smaller in memory, assuming you have a few unique values in the column. When you're ready to incorporate your data set into other Python libraries and analysis libraries, some of them can utilize categorical variables in their analysis. If we expect a column to be a numeric dtype, but has been loaded as a string, this is a typical sign of bad data that needs cleaning.
Yep.
In our example data frame, treatment A is stored as a string because of the missing value stored as a dash. In this example, we can use the toNumeric method on the column and the errors parameter to coerce values into a numeric. This will convert all the values in the column into numeric. For invalid values in the column, it will be set as a NaN missing value. If we do not pass in the errors equal coerce argument, then Python will return an error because it will not know how to turn the string dash into a numeric value. Now it's your turn to work with data types in pandas.
Okay, let's just do pandas, and that's what we have here. Convert data type. So we have category, right? Tips data set been loaded, data frame and tips. Look at the info. So we can just tips info function. So we got here total bill, tips, stacks, object, and you got flows over here. Smoke is object, day, time, size, object, right? And let's see, tips, head. So okay, so you see those values here. So you know that the two categories should be category sex and smoke, but instead of the object. Sex and smoke should be category, but instead of object. So we gotta convert those. Even though we're still arbitrary string, your job is convert those two category to the two type of category, reduce memory usage. Okay, it goes reduce memory usage. So sex equals sex. What's the syntax? I already forgot. Is that to here? As type Here we go. As type. Category. Tips. Obviously, want us to type again. As type. Category. And the print permission for tips in info. Practice typing. I've been typing for a long time. Seems like. On the code, the category is not defined. As type category. Yep. Here. We got a code. This guy. Code. Shift code. But if you identify manage info. Okay, now it's become category. Submit. Good. Next one. Work with numeric data. So, excuse me. You expect data type to the numeric. This type is objects to numeric. So set the coherence error equals to coherence. So this one will actually force the null to, I think, ignore the null. That's what it do. So what's the syntax? PD. So convert the total bill, because remember, like, you get tips, the info, right? Tips is object. We're gonna convert, obviously, because it should be a flow as not type numeric. The window is too big. Okay, let's put my face a little bit small. You don't need to see that. Tip tips equals to total bill, double quotes is okay. And here we can have coherence. Here compare tip to a numeric D type. Tips. Oh, do we have tips over here? Okay. Tips and total bill. Okay. So just type everything again. To numeric tips. Tip. ORS. Coherence. Bring the tips, the info. Run everything. Ta-da! Flow. See? Easy peasy. To numeric. Remember this one. Next. Excuse me. Okay. Use a regular expression to clean string.
Most of data cleaning will involve string manipulation, because most of the world's data is unstructured text. You will also have to do string manipulations to make datasets consistent with one another, so you can work with or combine them later. Let's first consider strings that contain monetary values. There are many ways a monetary value can be represented. An integer on its own, an integer with a $sign, a floating point number with a $sign and 2 digits after the decimal point, a floating point number with a $sign and multiple digits after the decimal point. We want a way to check and validate these values, and let us know if there's an error in our data, like the last point here that has 3 decimal values instead of 2. Python has a suite of built-in methods and libraries for string manipulation. The RE library for regular expressions is used for string pattern matching. Regular expressions give us a formal way to specify a pattern. It does this with a sequence of characters. We've seen some pattern matching before when we used the glom module. Here's a list of monetary values again. Let's write a regular expression to match each of the values. If we just wanted to match an arbitrary number of numeric values, we can use the regex pattern \d to represent any digit, followed by an asterisk to match it 0 or more times. For an integer that has a $sign in it, we have to do something different. The $sign actually has a special meaning in regex. It means to match from the end of a string. But in our example, we want the $sign to actually mean the $sign character. So we will have to do what's called escape the $sign. We accomplish this by using a backslash followed by the $sign. Then, to match the monetary value, we can use the \d asterisk just like before. To match a monetary value with decimal points, we can take the pattern we just wrote and extend it to match a period followed by more digits. The period, like the $sign, has a special meaning in regex. Instead of matching 0 or more times, like the asterisk, the period matches any one character. We have to escape the period as well with \period. Then, to match the decimal values, we can use \d asterisk. There's nothing wrong with the period's pattern, but we know that the decimal values in money are only 2 digits long. Instead of using \d asterisk to match the decimal values, we can use \d curly bracket 2 to match exactly 2 digits. Let's take the pattern one step further. We can take the previous pattern and put a caret in the beginning and a $sign at the end. The caret will tell the pattern to start the pattern match at the beginning of the value, and the $sign will tell the pattern to match at the end of the value. This way, it will match exactly what we specified in our regex. Otherwise, the regex would also match the string, I have 1789 USD. To use a regular expression, the most efficient way is to compile and start the pattern match at the beginning of the value, and the $sign will tell the pattern to match at the end of the value. Let's take the pattern one step further. We can take the previous pattern and put a caret in the beginning and a $sign at the end. The caret will tell the pattern to start the pattern match at the beginning of the value, and the $sign will tell the pattern to match at the end of the value. This way, it will match exactly what we specified in our regex. Otherwise, the regex would also match the string, I have 1789 USD. To use a regular expression, the most efficient way is to compile the pattern first, then use the pattern to match values. Compiling the pattern essentially saves the pattern into a variable that we can use to match over and over across multiple strings. This is useful when working in pandas because we typically want to match or validate values down a column of values. To use a regular expression to match monetary values, we compile and save the pattern with the compile function as seen here. We can use the match method to match the pattern to a string by passing the method the string we want to match. This will return a match object. We can convert the match object into a true-false Boolean value using the Python built-in bool. Here you can see our pattern matches the string we passed into the match method. Let's first practice writing regular expressions on their own before using them on columns of data.
Okay, let's do it. So string pass to regular expression. Thanks. Regular expression, which has a powerful way to find pattern. Looking at the data, sometimes necessary to directly express looking to proper entry value. Your job is match US number. Okay. Regular expression margin in Python are so got import RE. Compile the pattern first using compile. We compile. And use this to match X. Okay, so like star D means any number? I don't remember. Three digit. Is that like this? Three digits. And 4 digits. Pattern. 1, 2, 3, 4, 5, 6, 9. 2. We don't not actually compile. Oh. Match. Compile. Oh. Pattern matches. And match. So, oops. Oh no. Close it. Match. And now the patterns over here. Let's just count him. So basically, what they do is like, hey, like you first import the module and the module compiled. You have the regular expression, 3 letters or 4 letters, and if it's matching number, matching this guy, then the result equals to boolean say true false and next true false. So we can just like let's just run line by line. PROG, this guy, right? True. Okay, so this is a true. But how about this one? This should be false. Okay, so ta-da! Extract number from the string is the common task. 6 strawberry, 2 banana, 6 and 2 is a string. So find all. What are we gonna find here? So star D, right? Should be followed with a plus, so the previous element is a match one. One or more time. 10 is obviously one number is not as 110. What does that mean? Oh, okay. So I think we need a star size like this, and the print matches names. Not to find what you call import IE. Is that right? Oh, plus. Dun-dun. Plus is +1. Pattern match. What pattern here? Present exercise pattern. So it's like D, then 3 numbers, D, 3 number, D, X slash 4 number. Start with $sign and start with D, start with skip data, and D again. We got 2 over here because 2 digit over here. So straight. Seriously? String, I don't remember string. It's a pattern string. String. Didn't talk about anything about string. $sign? Oh, W. And length. Let's see, false, true. I don't know even. D3, D4, okay. Miss. Dash $sign. Oh, God, you just got that. You get that. Because we have 3 digits, so we gotta like add more, skip it, and add 2. Okay. True. Australia. Ta-da! Okay, next.
When we're cleaning data, sometimes the cleaning step we want to perform will require multiple steps. For example, if we want to extract digits from a string and then convert it from a string to a numeric, we can write a Python function to perform these steps and apply it across rows. Let's check out how to use apply. Here's a sample data frame. We can apply a function, in this case the mean, across each column of the data frame and get the average value for each treatment. We can also apply the mean function across each row by using the keyword argument axis equals 1. Here's a subset of a job application filings dataset. We want to check that the initial cost and total estimated fee to make sure it's a valid monetary value. Then, we want to remove the $sign and convert the string into a floating point number and find the difference between the two values and save it to a new column. If the entry isn't a valid monetary value, return a NaN missing value. Let's begin by loading the regular expression library and NaN missing value. We use the compile function to compile a regular expression pattern for monetary values. Next, let's write the function. You can learn more about functions in other DataCamp courses, but here's how you write them. You first define the function with the keyword def. Then you specify the name of your function, followed by your function inputs in parentheses. And you start defining your function after the colon. The body of your function will be indented. You end your function with the return statement and the output value. When we apply a function across rows of a data frame, what gets passed into the function is the row of data. Even though we only need a few values from the row, the entire row will be passed into the function. So, our function will take 2 parameters, the row of data from our data frame and a pattern we will use to validate monetary values. We can get the initial cost and total estimated fee values by slicing the row, and we can write an if statement to make sure the values are valid. We're using the pattern.match to take the compiled pattern we've passed into the function and checking to see if the pattern matches the value we give it. We convert the result into a true-false Boolean value. We use the Python AND operator to make sure that both the initial cost and the total estimated fee are valid monetary values before proceeding. Now that we have a valid monetary value, we can remove the $sign by replacing it with an empty string using the built-in Python replace method on strings. We can pass in the string we want to replace, the $sign, and the value we want to replace it with, an empty string. Finally, we convert the remaining string into a floating point number using the built-in float function and return the difference of the values. If the pattern did not match, we return a NaN missing value. To use the function we wrote, we call the applied method on the data frame and pass in the function we want to apply. Next, since we want the function to work row-wise, we set the access parameter to 1. By default, apply will work column-wise with the access parameter equal to 0. Finally, since our function takes multiple parameters, not just the row of data from the data frame, we pass in additional function parameters into the apply method. Here, the pattern parameter from our function diffMoney will be given the regular expression pattern we wrote earlier. In our example, the function we wrote returned us the difference between the initial cost and the total estimated fee. When it was applied across the data frame, we got a new series of values, one for each row of the data frame. We then created a new column in our data frame using this new series of values. Now it's your turn to write functions to perform a data cleaning step.
Okay, let's do it. Function, the name is the record gender. Wow, that's so hard, this function. If return 0 if the gender is equal to female. So if, let's see, sex contain male, female, right? Female 0, male's 1, and the return none for all the entries sex that needs a female, male. Equals to male, return 1. If gender, yeah, right, equals to, man, like, I don't know, like, is this syntax right? I mean, I don't think it's right. Then 1, else if equals to female return 0. The women's return non-Python 5 tips. Recode gender. Oh, it's not recode. If first passing two parameters, right? tips.sex. Should be like this. Tips.sex. Right. Enter x and s equals to 1 and what else? I don't think this is correct. Let's see. And equals to 5. The female. Okay. What? Oh. The Saxon is not working. But Sax not working. Look at the hand. Still don't know the answer. Let's see the answer. Oh, that's it. Wait, I saw male, female, gender. Wait, that's it? I thought the slides are different. So you're gonna apply for them. This is a function how to name. Yeah. You apply the equals to 1. Oh, okay. Pattern equals pattern. But if you don't define, is that defined by a column? So you don't even need this one. One, 0. Did you return that? Yes. Oh. 0 equals to 1. Ta-da. Next, lambda function. So square is 2 minus square x equals lambda. Okay. Let the lambda function replace lambda x replace to this. Lambda function x equals to x dot place common expression 0 to what? First argument is find all function complete on from all. No attribute. Okay, how to slice. Let's see the answer. I didn't get it. Why here use RE? So the complex technology must visit element as the first in the body of the function user, which accept the two values, the pattern and the string, to find the pattern. Oh, the pattern and the string. Still don't get it. Number, number, number dot number. Okay. Well, I guess that's it. Duplicate missing data. Let's see that.
Now that we learned the methods on how to clean data, the last step is to deal with duplicates and missing data. Duplicate data is problematic as it can affect your analysis in undesirable ways. We can drop duplicate data with the drop duplicates method. Here's an example of a data frame with duplicate data. You can see the first and last rows are exactly the same. To drop duplicates in our data frame, we call the drop duplicates method on the data frame. You can see, after we call the method, the duplicates are dropped. In this case, the last row of our original data frame was dropped. Now let's work with missing data. Here's an adapted tips data set. This data set gives the total bill and amount of tip given for the bill. It also includes other information about the sex of the table, whether there are smokers, the day of the week, the time of day, and the size of the party. You can see the NaN missing values in our data. There are a few ways you can deal with missing values. You can leave it as is, drop them, or fill using various pandas methods. Just like dropping outliers from your data, dropping missing data also needs to be carefully considered. Data can be missing randomly, or there may be a systematic problem in your data that introduce missing values. Remember, we can use the info method to get a count of NaN missing values. In our tips data, you can see we have 244 entries, but no column has that many non-null values, meaning we have missing values in each column. To drop missing values in our data frame, we use the drop NA method on the data frame. If we look at the info of our new data frame, we now only have 147 entries, and each column also has 147 entries. What we get is a data frame with only complete cases. That is, if a row contains a missing value, then the row will be dropped from the data frame. We lost about 40% of our data with this method. If we only lost a few observations, that would be reasonable. But with this many observations dropped from our data set, we need to deal with missing data differently. Keep in mind, dropping columns is also a possibility if most of the missing values are from a particular set of columns. You'll see this in the exercises. To fill missing values, we use the fill NA method. There are various ways we can fill missing values. We can fill it with a user-provided value or some summary statistic like the mean or median. We can fill any NaN missing value with a user-provided value using the fill NA method. Here, I'm recoding all the missing values within the sex column to the string missing. We can also recode missing values from multiple columns at once. To select multiple columns from a data frame, we can use the double square bracket notation. Here, I'm subsetting the numeric columns, total bill, and size, then recoding all the missing values in these columns to 0. You can see now, when we look at the info, total bill, size, and sex columns no longer have missing values. We can also fill missing values with a test statistic. However, we have to be careful if we want to use a test statistic like the mean to fill in missing values. You have to make sure the value you're filling in makes sense. For example, the median would be a better statistic if you have outliers. Here I'm going to fill the missing values in the tip column with the mean of the tips. We first calculate the mean using the mean method on the column. And we can replace the old column values with the new column values using the fill NA method like before. If you look at the info once more, the total bill, tip, sex, and size columns no longer have missing values in them.
Okay, so let's do it. Fill billboard, right? Like you do data frame for tracks. Create a new data frame track. So is that like this? Artist, not quite sure, and track. And time, right? Let's run through that and the info. Okay. object, right? No, duplicate. Track. Let's see how that looks like. Right. Tracks drop to duplicates. Track verify. So previously it's got that much of row. Now it's got 307. Wow, okay, that's a lot dropped. I've filled missing data. Ozone dot air quality. I don't think it's right. Domain. And now equals to wait a second, this is a data frame. On some column. Don't think that's right. Hit. Wait a minute. Oh, okay, now with this. Oh, test assert.
The last topic I want to cover is on testing. We can use assert statements to programmatically check our data versus visually checking it. For example, after we drop or fill our missing data, we expect to have 0 NaN missing values. We can write an assert statement to make sure that there are no more missing data. By writing assert statements in our analysis scripts, we can detect early warnings and errors in our data before the final analysis results. This gives us confidence that our code is running correctly and helps when we rerun an analysis with updated data. Here's how assert statements work. If you give it something that evaluates to true, it will return nothing. If you give it something that evaluates to false, it will give you an error. Let's apply this method to our data. Here's the head of some stock data for Google Alphabet. We have the date, the open, daily high and low, and close stock prices, along with the volume and adjusted close. Now, let's write an insert to test for missing values. I use the not null method on the column to check for missing values. This will return true if there is a value and false if there's a missing value. I'm chaining the all method to test if all the values are not null. But here you can see assert raised an error, meaning there are missing values in the data. I can fill all the missing values in the data frame with the value 0. And now you see the assert statement does not return anything, meaning we do not have any missing values in our data. You'll get more practice with asserts in the last chapter, but for now, let's practice writing assert statements.
All right, let's assert it, right? There's no missing value. Online together is not null. True, false, true, true, false. 一波澜。Data frame. 一波澜。Yeah, some people on data frame. OK。PG 加true false. First one is the true false is column, and second all is we return single true and false. This is true. This is true. What this guy? Oh, true and false. Okay. Good. So guys, this is all we got today, and I hope you're enjoying the data type. And stay tuned, and we will go to next episode soon. Peace.